Welcome to Start Lecture. This is the continuation class from the previous class. Okay, this is the part 2 of the trigonometry. Here we learn about trigonometry ratios for the specific angles. In the last class, we learned about some of the trigonometry ratios. Okay, so we will recollect in few minutes what is studied in the last class. So if you take a right angle triangle, that is ABC, so it forms the right angle at the B is 90 degrees. Okay. So if you take other acute angles like C or E, okay, let's take C angle is theta. Okay. So one of the ratio is opposite side to hypotenuse. That is sin theta. Right. So here, what is opposite side to the theta? It is AB. Okay. Hypotenuse is AC. So sin theta is AB by AC. Right. Similarly, we have taken to the cos theta is adjacent to the theta. Okay. So what is the adjacent side to the theta? This is theta, this is the hypotenuse, right? What is the adjacent side? It is the BC is the adjacent side. Okay. So BC is the adjacent side and hypotenuse is AC. Okay. So when you take the tan theta is opposite side to the adjacent side. Okay. What is the opposite side to the theta? It is AB, right? So it is AB by, and adjacent side is BC. Okay. So then the secant theta is all reverse of the one sin theta, and secant is reverse of cos theta, and cot theta is reverse of the tan theta. Okay. So these ratios get reversed here. Okay. So we learn that. So these edge ratios are constant for the given angle. Okay. Let's take the given angle is theta. Okay. For the corresponding edge ratio, okay. For example, I am taking the edge ratio of the opposite side by hypotenuse, that is AB by AC, okay? So that we are taking as a sine, right? Okay. So these ratios are constant for the different angles, okay? So that if you know the angle, you know the edge ratio. If you know this ratio, then we know the angle, okay? So the most commonly used angles I am writing here, for all the angles, you will be having the edge ratios constant, okay? So, for example, this angle is 30 degree, you have the edge ratio of 1 by 2, okay? If this is 45 degrees, then this ratio is 1 by root 2, okay? If it is 60 degrees, then this ratio is root 3 by 2, okay? So, like that, it has the different constant for the angle, okay? So, if you know this angle, then you will know this ratio, okay? Similarly, if you go on take the other ratios, like right adjacent side to the hypotenuse, okay, that is also related to the theta, and if you take the adjacent side like right BC by and take the hypotenuse, okay, this we are denoting as a cos, okay. Here is the ratio for 30 degrees, this ratio is root 3 by 2, okay. For 45 degrees, this ratio is 1 by 2, okay. Similarly, 60 degrees, this ratio is 1 by 2, okay. So, okay, if this ratio is coming like 1 by 2, then we will say that this is for 60 degrees, okay. So, you get these edge ratios for any angle by the graphical way very easily, okay. So, let's see how to get these edge ratios for the different angles. So, let's take the graph sheet. Or you can take the any plain paper also, okay. So no problem. Okay, you can take the graph sheet or you can take the plain paper. Okay, let's mark point in this paper or graph sheet. Okay, so I'm just marking one point over here. So I'm just taking this point is A. Okay, and I'm dropping on a horizontal line. Okay, by using ruler. Okay, by using ruler, I'm just making a horizontal line. Okay, now take the protractor at the A. Okay. And you just mark the whichever angle you want to measure these ratios. Like these edge ratios, like opposite side by hypotenuse, this, all the ratios, right? It does not depend on the size of the triangle, okay? Only it depends on the angle of the triangle, okay? For example, I want to measure this one for 30 degrees, okay? I'm just marking the point here at 30 degrees, okay? So I'm just marking the point 30 degrees here, okay? And using your ruler, right, scale, you just join these 2 points, okay? From the point A, just join So now you have drawn two lines with the angle of 30 degrees, right? So this is the point A. So this is the angle 30 degrees you have drawn, okay? Now you can draw it any place vertical line, okay? By using the again protractor, you can draw the vertical line from this horizontal line, okay? So that it will form the 90 degrees at angle, okay? So let's draw a vertical line anywhere, okay? So it won't change these ratios accordingly with the size of the triangle. So we can draw any place vertical line by using the protractor, okay? Let me draw at any place like this, something like that. I can draw it here, right? So I'm just drawing a vertical line here, okay? Similarly, you can draw anywhere. It's okay. I'm just drawing another, okay? Let's mark these points. So this is the point B, and this is the point C, and this is the point B, and this is the point E, okay? So now it formed the right angle triangle ABC, okay? So at the angle, this is the now with the scale you measure this distance AB, okay? And also you measure the distance BC, okay? And also with the scale you can measure the distance AC. Now you know the AB distance and BC distance and AC distance, right? So that we can calculate all these angles, okay? Let's see. I have drawn a very approximately here, okay? So that it may not get the exact number, but if you draw it in proper scale and right, you will get the accurate number. Let's take AB is how much. So I'm just taking the units. It is a 1 box, 2 box, 3, 4, 5, 6, okay? I'm just taking 6. How much you have the vertical here? So 1, 2, 3, and it's around the middle of this, right? So it has some 3.5, okay? If you use the Pythagoras theorem, you can find the CSE, or you can measure with the scale directly, okay? You will get this distance around like 6.9 or 6.92. If you want to know the sin theta, okay? What is the sin 30 here? Okay, I'm just writing sin 30. It is the opposite side to the hypotenuse, right? What is the opposite side? That is here, marked with the point C, right? So the BC by hypotenuse is AC, right? So what is the BC? BC is 3.5, okay? Divided by 6.9, right? So if you do this ratio, you will get like 0.502, or it is approximately, it's equal to 1/2, okay? So that's the reason it is sin 30 is 1/2, okay? So this, similarly, if you do it for the cos 30, okay? So cos 30 is the adjacent side to the angle, right? That is AB by hypotenuse. What is adjacent side? It is a 6, right? So 6 by, what is the hypotenuse here? 6.9. Okay. So if we do it here, we'll get around 0.86, right? This is almost, the value is equivalent to the √3/2, okay? This 0.86 is √3/2, okay? You can check with your calculator. Okay, similarly, even not only this triangle ABC, okay, any triangle like vertically like ADC or any triangle if you take, right, you will get the same ratios. So you need to understand that it depends only on the angle, not on the size of the right angle, okay? So there's a tabulated or in the calculator, right, you will be having these ratios for all the angles like 1, 2, 3, 4, 5, like that. For all the angles, you have these ratios. Yeah, if you can do this exercise, okay, if you have any questions, you can make in comments, okay? Graphical method to derive these edge ratios, okay? Now we'll discuss some of the trigonometric ratios of some specific angles, okay? So we do some analytical derivations to get the trigonometry ratios, okay? Mostly commonly used angles for the academic purpose, it is 30 degrees, 45 degree, and 60 degree. So we'll see the constant ratios for the each angles. What are those ratios? Sine means some specific sine ratios on cos, then tan. Okay, critically, let's start for the first for 45 degrees. Let's take a rectangle triangle. Okay, so this corners I'm just marking ABC. Okay, let's take for 45 degrees here. Okay, why you have to take in 45 degree here? We want to get the ratios for the 45 degrees, right? So in this, we know that this is 90 degrees. So this angle is 45 degree. Obviously, this angle is 45 degree. Why? So the sum of the three angles must be 180 degrees, right? That's why these two angles are 45 degree. Okay. Now we know that its angle A is equal to angle C, right? So if these two angles are same, we know that the opposite sides are the same. If you need derivation for this one, I'll take it into the other class, okay? So if let's assume something like this, okay? The principle is like this, okay? If the two angles are same in the triangle, let's take the opposite side of this 45 degree angle. So that is BC must be equal to, okay? So what is the opposite side of this 45 degree angle? Is the AB. So those must be equal, okay? So let's take BC is equal to AB is equal to, let's take a small a, okay? Now we can find out the AC. So this is A and this is A. We have taken A. How do you find for the AC? We know the Pythagoras theorem, right? So let's take the Pythagoras theorem. Okay. What is the Pythagoras theorem? So the hypotenuse square equal to both side squares, like AB square plus BC square. So this is the longest hypotenuse square to the two other sides, like AB square plus BC square. So we need to find the AC square. What about AB? It is a small a. We have taken this distance, right? So it's a square, and it is AB also. So AB is a square plus BC is also a. So it's also a square. So it has the 2a square, okay? How many a squares? 2a squares. So if you put for the AC, it must be square root of 2a square, okay? That's equal to square root 2 into a. A square is become a. We made the square root, okay? Now let's find for all the trigonometry ratios, okay? Let's take sine 45 at angle C, okay? So what is that? What is the sine shows? Is the opposite side, right? That is AB by hypotenuse, that is AC. What is AB? It is A, right? What is hypotenuse? Is a root 2 into A, okay? So that became 1 by root 2, okay? Similarly, if you want to do it for the cos 45, okay? Cos 45 at angle C, okay? I'm doing it at angle C. So its adjacent side for the angle C is adjacent sides which are touching to that angle. Forget out the hypotenuse, okay? Don't that is separate. We'll be calling only these two sides. They'll call the names with opposite side and adjacent side. For this 45 degree angle, the adjacent side is BC, right? So we'll take the BC by hypotenuse is AC, okay? So what is BC is A, and hypotenuse we know that root 2 into A. That's equal to same A is get cancelled. So it's 1 by root 2, okay? Similarly, if you do for the tan 45, what is the tan 45? Opposite side by adjacent side. What is the opposite side for the 45 degree? It's a AB, right? So AB by, what is the adjacent side? It's a BC, okay? So that become A by A, okay? That will become 1, okay? Now we know that three edge ratios. One is the opposite side by hypotenuse is 1 by root 2 and adjacent side by for this angle. So adjacent side by hypotenuse is also 1 by root 2 and the opposite side by adjacent side is also 1, okay? So regardless of size of this triangle, okay, it's keep increasing the size of the triangle, these ratios will not change, okay? It only depending on the angle, okay? So now we have proved for the 45 degrees on sine, cos and tan, okay? How do you get cosecant, secant and cot? Cosecant is a reciprocal of sine, right? So for that, you know, if you are going for a cosecant, it is a 1 by sine, right? 1 by sine. So if you go for cosecant 45, you become 1 by sine 45. What is 1 by sine 45? You become root 2. Okay. Similarly, secant 45 to become 1 by cos. Okay. Then that is also will become root 2. What about cot 45? 1 by tan, right? That is also will become 1. Okay. So now we have derived the ratios for all the trigonometry ratios. Okay. Sine, cos, tan, cosecant, secant, cot. Okay. Now let's see for the 30 degree and 60 degree. derivation for the 30 degrees and 60 degrees. Okay, let's take a equilateral triangle. What is equilateral triangle? So all the angles are same in the equilateral triangle. This angle is 60 degrees, this angle is 60 degrees, and this angle is 60 degrees. Okay. Now let's draw a vertical line from the one of the corner. Okay. Such a way that it will make 90 degrees formation on the BC. Okay. So the line which we have drawn is perpendicular to the BC. Okay. So now we have drawn a line. So the angle over here is 90 degrees. Okay. We know that from the equilateral triangle. So this, when you make the perpendicular into the any of the other side, okay, it divides this BC into equal parts. That means let's take this point as D. Okay. So it will divide into the equal parts. That is BD is equal to BC. Okay. Now, what will happen to this angle? This angle will become 30 degrees and this will become 30 degrees. Okay. The 60 will become bisected because it's equilateral triangle, right? AB, let's take the AB length as 2A. Okay. Yeah, you can take it A also. AB, you can take it A. Then BD will become the half of that, right? So it will become like A by 2 and A by 2. Okay. That will create the little bit tricky in the simplification. Okay. If you take it AB is equal to A, it will become more easy for you for the calculation purpose. Okay. Nothing wrong if you take this is A and this you can take it A by 2 and this has become the A by 2. So I just took the AB length as okay, 2A. Let's take, okay, this is called take. Okay, you can take it anything, okay, which you do not know, right? We'll assign a variable to it like it, etc. So that I just assign AB length as 2A here, okay? So if AB length is 2A, right? Then what happened to the BD equal to BC equal to, it will become A, right? So the total BC is 2A here, right? Again. So that half of the length, right, BD and DC will become half of it. That's become A, right? So now BD and DC is equal to A here. So let's find the AD here, okay? So that we can know that all these sides from that, okay? So I'm just writing here, whichever we know here. This is 2A we have taken. That's we have taken. So that the BD will become, this is small a and this is small a, okay? So now let's find the AD, okay? How do you find AD? Let's take the triangle ADB, okay? Let's take the triangle ADB, okay? So this is a right angle triangle. And if you use the Pythagoras theorem here, hypotenuse square equal to, that is AB square, okay? So that is AB square equal to AD square plus BD square, okay? So that will become like AD square plus BD square. Clear, right? So now what do we need to find here? We need to find the AD distance here. Let's keep one side AD, okay? So AD square is equal to AB square minus BD square, okay? I just send this BD square to other side, right? So now, what is the AB square? AB we have taken as a 2A, right? So let's substitute 2A here, okay? 2A whole square is equal to BD square. What is the BD? It is A here, okay, right? So it is a square, okay? So now this AD square is equal to 2A square minus A square. Okay, what is 2A square? 2 square means it's a 4. A square means it's A square, right? So, okay, minus it's A square. What do we get here? 4A square minus A square is 3A square, right? So, then what about this AD distance? AD, when you go to square here, we go to square root, okay? Square root 3A square. A square root is A, right? Let's keep the root 3 as same into A square will become root 3 into A. Now we know in the form of A, to all the distance like BD, AB and this height AD, right? Now let's find our trigonometry ratios. Okay, let's take any triangle, this triangle or this triangle. Okay, let me take triangle ADB. Okay, what is the triangle at the point A? Okay, it is 30 degrees, right? For this triangle, it is 30 degrees. Okay. Now, if you take sine in this, okay, Sine 30. Let's take sine 30 here. Okay. What is a sine 30? Sine means it's the opposite side by hypotenuse. Okay. What is opposite side? BD is the opposite side for this triangle. Okay. I think if you draw separately this triangle, then it will be more convenient for you to simply draw. Okay. Because of two triangles, it will get confusion. Okay. So just imagine only this triangle. Okay. So if sine 30 means its opposite side is, what is the opposite side to the sine? It is a BD, right? So BD by, what is the hypotenuse here? Is a AB. Okay. So if you put it, what is the BD here? BD is the A. What is the hypotenuse here? 2A, right? So AA's get cancelled. We get 1 by 2. Okay. Sine 30 we have the 1 by 2. Similarly, if you put for the cos 30 there, okay. Cos 30 means what is the adjacent side by hypotenuse. What is the adjacent side for this 30? This is the adjacent side. Okay, this is the hypotenuse. So this is the adjacent side. So it is AD by hypotenuse is, what is that? It is a AB. Okay. What is the AB here? AD we derive the root 3 into A. Okay. Let's keep root 3 into A. Okay. What about AB? AB is 2A. So A is get cancelled. It is root 3 by 2. Okay. Now let's take this angle. Okay. 60 degrees angle. Let's take 60 degrees angle. Okay. Sine 60 equal to opposite side by hypotenuse. What is opposite side? It become AD by, what is hypotenuse? AB. Okay. Then what is the AD? AD is root 3A. Okay. Root 3 into A. AB is 2A. Okay. So that sine 60 will be root 3 by 2. Okay. For cos 60. Okay. Let's finish in this cos 60. Okay. So now for cos 60 equal to adjacent side is BD by hypotenuse is AB. What is the BD? Is A. What is the hypotenuse here? It's a 2A. So we get 1 by 2. Okay. Now we derived these ratios for the sine 30, cos 30, sine 60 and cos 60. Right? So now, how do you get for the tan 30 here? It is sin 30 by cos 30. Or you can take directly tan 30 here. Is the opposite side, right? BD by, what is that? AD, right? So BD by AD. What is BD? It is a divided by AD is root 3A. Okay? So tan 30 will become 1 by root 3. Similarly, tan 16 is here, right? So opposite side is AD by BD. Okay? That's equal to AD is root 3A divided by A. That will become root 3. Okay? Now all other angles we can get the reciprocal of this one. Like cosec angle you will get 1 by sine, right? Sine 30. If you take cosec 30 degrees, it will become 1 by sine 30, right? Similarly, secant 30 to become 1 by cos 30. Okay? Similarly, like cot 30, it will become 1 by tan 30. Right? Now we will see these trigonometry ratios for the two other angles like 0 and 90 degrees. So these are the imaginary things. Okay, so you don't form the triangles actually with 0 or 90 because the two summation of these other two angles must be 90, right? Then if it's become 0, then other must be 90. They are never having the any triangle actually. But these values are also very important. Okay, while calculating, those are realistic also. So I'll explain how to find these angles for the different trigonometry ratios. Let's take a right angle triangle A, B, C. Okay, so this is a right angle triangle, and let's think that this is the angle this jagged angle, we are going to find the ratios of that. Okay, let's take this angle. Okay, theta. Okay, sin theta. Okay, how do you write for sin theta here? It is AB by hypotenuse like AC, right? So AC. Okay. Now, what will make right if you want to find the 0 and 90 degrees? Let's think that, okay, now this theta is going to be 0. Okay. How it will go to 0 here? This A point is keep coming down, right? Then this theta is keep decreasing, right? Then this angle is keep increasing. Okay. Let's draw another line here like this. Okay. So what happened this theta angle when you take this another D point here? Let's take this triangle. So obviously this theta become the reduced its angle, right? Reduced its angle, and this angle is increasing. I said in the initially of this my class itself, right? One angle is decreasing, another angle will increase. Okay, to maintain the 90 degrees. Okay, so when this keep going down here, this angle is keep decreasing. Okay, and this angle is keep increasing. Okay. Now, for the new theta means it's a smaller, right? Okay. So what to write when we are keep decreasing this hypotenuse, right? This hypotenuse is the AC, right? So this when we are keep decreasing this hypotenuse is going to match with the BC. So it's going to flat here. Okay. That means let's take 1 degree angle. Okay, let's take one when it has become the 1 degree angle, almost right. This line will be like this. Okay, I will just draw a line. Okay. So I draw a line here, triangle. Let's take this point is E. Now there is a triangle formed between E, B, C, right? So when initially it has the larger theta, okay, then theta going down. Let's take when it comes to 1 degree angle, okay, then this opposite side, this theta is this opposite side, AB is keep reducing to BE, right? So, okay, so BE will become very small, right? If you are going 1 degree, BE is a very small number. If you go further down, like 0.1 degree, 0.01 degree, like that, this BE will become almost 0, okay? So that's why we are trending. This value will go to 0. Okay. Then theta will become 0. Then this value also will become 0 is the point here. Okay. So in this scenario, when you're taking sin 0 here, okay, then this AB will be almost reducing and it's going to be 0. Okay. Then what will happen to AC? Okay. When AC is here, then this AC going down, right? So this line and BC line will matches. That's imaginary. Okay. It never formed the triangle, but we'll take these numbers are very convenient for the trigonometry ratios. Okay. So then this AC will become the BC. Okay. So anything 0 by anything, we know that it's a 0. Okay. That's why sin 0 is 0. Okay. Now let's evaluate similar to the cos 0. Okay. What is cos theta? First we'll write the cos theta. Okay. For cos theta is BC by that means adjacent side by hypotenuse AC, right? Okay. Now it's a full angle here. So the BC, when theta is keep decreasing, okay, BC is going to change anything? No, right? BC will be the constant. Only this A point is keep moving down and become 0. When theta wants to become 0, only the A point is keep moving down and it will become 0. Okay. BC is not going to change anything. Sorry, BC is not going to change anything. Divided by, what about the AC here? AC, when it is going to 0, this AC is keep going and it is trying to match within the BC line. Okay. So we will take roughly when it is become 0, this will become BC. Okay. That's the assumption. Okay. It never formed the triangle. That's what it's saying. So when it is going to 0, then this AC will become the BC. Okay. Then we will get the 1. Okay. That says we will take cos 0 as 1. Okay. So now we derive two things. One is cos 0 as 1 and sin 0 is 0. Okay. Similarly, we will define sin 90 and cos 90. So if we rewrite here for sin theta, it is initially it is AB by hypotenuse like AC, right? Now let's see this theta is going to 90 degrees. So earlier we sent theta to 0, now theta to 90 degrees to calculate the sin 90. Okay. So what is sin 90 here? Sin theta here, opposite side AB. Okay. When it will become theta 90 degrees, let's assume this C point. Okay. Now C point moving towards B. Okay. Let's fix this AB and this is keep moving here. Okay. When it's coming up to here, it will become like 89 degrees. And when it comes very close, it 89.1, 89.2 and to become 90 degree. And matches, you cannot form the triangle, as already said, right? We'll keep it like 0.001 degree less. Okay. That's the reason it will form the triangle. That means, so it's almost 90 like that. Okay. So when theta is trending to the 90 degrees, the C point will move to the P point, right? So now what is the sin theta? It's the opposite side. What is the opposite side? AB, right? So AB is going to change anything when the C point is moving? No, right? That's the reason sin 90. So AB is not going to change anything. What is hypotenuse? AC, okay? AC will become AB, okay? When it reaches, so that it will become 1, okay? Sin 90 is 1, okay? Similarly, cos 90, okay? Put cos 90, when this point, what is adjacent side, right? Adjacent is BC, okay? So this BC keep decreasing for this theta, right? So that it will become 0, okay? When it become 90 here, then it will become 0 and 0 by anything like, right? This AB, this AC will become AB, okay? Then this is 0, okay? Cos 90 is 0. And sin 90 is 1, okay? So now we derived all sin 0, cos 0, sin 90, cos 90. Let's take tan 90, okay? Tan 0. What is tan 0? You know, right? Sin by cos is tan, right? Sin 0 by cos 0. Okay. What is sin 0? Sin 0 is 0 by, what is the cos 0? 1, okay? You know that 0 by anything is 0, right? So tan 0 also 0, okay? Let's take similarly tan 90 is equal to sin 90 by cos 90, right? What is sin 90? It is a 1, okay? What about cos 90? It's 0. So anything by 0 is undefined one, right? So we cannot divide it 0 times anything, okay? That's why they're calling undefined, okay? We'll get the undefined number for the tan 90, okay? Now I'll make a table for this, okay? Okay, so all these trigonometry ratios were derived this ratios, okay? So I'll say you, if you just remember only one line, okay? For the sign, if you remember these ratios, okay, you can get entire table very simple, okay? So you know right, just before we derived for sin 0 is 0, right? Sin 0 is 0 and sin 30 is 1 by 2, okay? Sin 45 is 1 by root 2 and sin 60 is root 3 by 2, okay? And sin 90 is 1, okay? So how do you get this cos, okay? I said that if you remember only one, you will get everything else, okay? So how do you know cos? So it is a 90 degrees. Let's take this angle theta, okay? Okay, then what about this angle? Sum of the three angles will be 180 degrees, okay? So 90 degrees is going for the B, okay? So angle A and angle C will be, so angle A plus angle C is 90 degrees, okay? Let's take angle C is theta, okay? Then what about angle A, right? So theta is equal to 90. So angle A is 90 minus theta, right? This is 90 minus theta, okay? Now, if you write sine for this angle, okay? Sine theta, okay? What is sine theta? It's opposite side by hypotenuse, right? Opposite side is AB divided by hypotenuse is AC, right? Okay. So, if you write for this angle, if you written the cos, not for this angle, if you written for this angle cos 90 minus theta, okay? So for this angle, what is the cos theta? Adjacent side by hypotenuse. For this angle, what is the adjacent side? AB, right? So it will become AB divided by what is the hypotenuse? It is the AC, right? So if you observe these two equations, the right side AB by AC is same, okay? That's why the left side two are equal. Like sin theta is equal to cos 90 minus theta, okay? So this is valid, okay? For example, when you are putting here, okay, when you are putting here theta is equal to 30 degrees. Then what about sin 30 here is equal to cos 90 minus 30 is 60, okay? So sin 30 will become cos 60, okay? Similarly, you can take it everything, okay? So cos will become the reverse of the sin, okay? We need to just subtract the 90 degrees and see, okay? For example, if you want cos 0, okay? Cos 0, you know sin 0. I'm just saying, if you want to calculate here cos 0, right? So cos 0 also can be written sin 90 minus 0. So that's sin 90. So how much sin 90 is the 1, okay? So sin 90 is the 1 here, okay? Similarly, for if you want to go cos 30 can be written sin 90 minus 30, okay? That is sin 60. What is sin 60 here? Root 3 by 2. Okay. Similarly, if you do for everything, okay, you will get it. This is 45 minus 45, you will get 1 by 2. And this is 1 by 2. And this is 0. Instead of that, all this, right, we'll just reverse it, okay. I'm just making to understand, okay, instead of simply following. First, you need to know the things. Then you can follow some simple tricks, okay. So here, you written, right, this. If for cos, we need to be just reverse the numbers. Like 1, root 3 by 2, 1 by root 2. Sorry, this is 1 by root 2. Same 1 by root 2. And 1 by 2 and 0. Right? So, what about tan? Tan is sin theta by cos theta. If put it here, 0 by 1, how much is 0, right? Good. So, 1 by 2 divided by root 3 by 2, okay? 2 get cancelled, it will become 1 by root 3. Okay? It is 1 by root 2 by 1 by root 2 to become 1. Okay? Here, root 3 by 2 divided by 1 by 2, it will become root 3. Right? So, 1 by 0 is undefined. Okay? Anything by 0 is called undefined. Undefined. Okay. Now, let's come to the cosec. Okay? It is a reciprocal of sine. Okay? So, sine is right. So, reverse of the sine. Okay? So, what happened? Reverse of the sine is 0. What is the reverse of sine? So, 0 by anything, it become like by 1, right? Understand, right? 0 means it's 0 by 1. That's the meaning, okay? Reverse of this means it's 1 by 0. 1 by 0 is also undefined. Similarly, if what about this sine here? It will become 2. It will become here root 2. Reverse. Here, root 3 by 2 will become 2 by root 3. Okay? Here the reverse is 1, reverse is also 1, right? Similarly, second, okay, is the cos theta when you take here. Cos theta is 1 here, the reverse is 1, the reverse is 2 by root 3. Here 1 by root 2 will become root 2, and 1 by 2 will become 2, and here 0 reverse, okay, 1 by 0 is, this is undefined again. Okay, now let's come to the cot theta, it's 1 by 0. This will become undefined. Okay, this is the reverse is root 3 and this reverse is 1. This reverse is 1 by root 3. Cot theta is the reverse of tan, right? That means it is a cos theta by sin theta. Tan theta is sin theta by cos theta, right? Reverse of cot theta means cos theta by sin theta. That means it is 0 by 1. 0 by 1 is anything is 0. Okay, that's why this number will become 0. This is the end of the class. Okay, the next class we will see about some of the trigonometry identities. Okay, identities, and we will solve some more example problems. Okay, thank you. If you like the video, please press the like button and share with your friends. Thank you.